video, we're going to apply what we learned about simplifying square roots to simplify more complicated expressions. So for instance, one like this. Square root of 50 over 2 to the power of 1/2. Let me write that a little clearer. So this one, we have different options for how we could solve it. But let's look at doing it this way. So let's start by simplifying this square root. So let's just take it, we can just take it off to the side for now, square root of 50. If you remember, 50 is not one of our perfect squares. We got 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and 16, 25, 36, 49, 64, 81, 100. Then we got 121, 144, 169, 196, 225. So this is not one of our perfect squares. So we're saying which one of our perfect squares can go into 50? And that's going to be 25. 50 we can rewrite as 25 times 2. And square root of 25 times square root of 2. Square root of 25 is 5. Squish them together to get 5 rad 2. So now we know we can replace this square root of 50 with 5 rad 2. And on the bottom, what do we also notice? Power of 1/2 is the same thing as square root. So we can rewrite this as square root of 2. Now notice we have the same thing on top, same thing on bottom of the fraction. They cancel each other out because anything over itself equals 1. So in other words, it's going to cancel. So we're just left with 5. So if you notice, there's another way we could have solved this. You could have rewritten 50 as 50 to the 1/2 power. Now they both have the same exponent, so pull it out. And we'd have 50 over 2 to the power of 1/2. 50 divided by 2 is 25. 25 to the 1/2 power is the same thing as square root of 25. Square root of 25 is 5. So notice we got the same thing either way. But for this portion, we're going to practice it this way. And on the classwork, we're going to do it this way as well. So let's look at another one. Let's say we have square root of 27 over 3 to the 1/2 power. So first, let's go ahead and simplify this square root. And we can just take it off to the side for the moment. 27 is not one of our perfect squares, but what number can go into 27? That's going to be 9. So we're going to rewrite this as square root of 9 times 3. Square root of 9 is 3. 3 we can't do anything with, this other one here. So that just stays. And so we have 3 rad 3. So now we know we can rewrite square root of 27 as 3 rad 3. And on the bottom, we have 3 to the 1/2 power. 1/2 power is the same thing as square root. So now we have a square root 3 on top, square root 3 on bottom. Cancel out, leaving us with a 3. So let's go ahead and try a practice. Let's say, let's try to mix it up a little bit. Let's say we have, let's say 2 to the 1/2 power over square root of 32. Yeah, let's go ahead and pause the video and try that out. 2 to the 1/2 power over square root 32. All right, let's have a look. So let's start by simplifying this square root. Square root of 32. 32 is not one of our perfect squares, but it turns out that 16 can go into 32. So we'd rewrite this as square root 16 times 2. Break them apart. Square root of 16 is 4 because 4 times 4 is 16. Squish them together, 4 rad 2. So we can rewrite square root 32 as 4 rad 2. So we have 2 to the 1/2 power over 4 rad 2. We can rewrite 2 to the 1/2 power as rad 2. We have the same thing on top, same thing on bottom. So these cancel each other out, leaving us with, careful, our answer is not 4 here. This one has a little twist from the last ones. What is our answer? Not 4. It's going to be 1 over 4. So we didn't mention this last time, but technically, when we're simplifying a different one, like say we have, let's say we have 7 rad 2 over rad 2. The rad 2s would cancel, leaving us with just 7. But really that 7 is up top on this fraction. So we still have this line underneath the 7. And if there's nothing left, these cancel out and become 1 or 1 over 1. So there's still technically a 1 on the bottom, but anything over 1 is just itself. But when the 1 is on top, you can't just make the 1 disappear like that. So here, the 2's canceled out. We're left with a 1 on top. So we have 1 over 4. That 1 has to stay there. So that's our answer for this one. Let's go ahead and try one more. Let's say we have square root of 75 over square root of 300. So this one will be a little bit different than the last ones, but try to simplify this so that there are no square roots left at all. See what you can come up with. So let's pause the video and try this one out. Square root 75 over square root 300. All right, let's have a look. So again, our goal is to simplify, to get rid of any exponents, any square roots, any roots in general. And so we may not be sure what to do right away. But one of the tools we have now is to try simplifying a square root, and maybe something's going to cancel out. Because as is, it doesn't look like anything's going to happen. So let's try simplifying both of these. We have square root 75. We have square root of 300. 75, if you remember, we did this earlier. 75 is 25 times 3. So we have square root 25 times square root 3, which is 5 rad 3. Over here, this is what number can go into 300? That's going to be 100. 100 times 3, square root 100 times square root 3, which is 10 rad 3. So we know square root of 75 is 5 rad 3, square root of 300 is 10 rad 3. So let's go ahead and swap those out. 5 rad 3 over 10 rad 3. The rad 3's can cancel each other out, and we're left with 5 over 10 which will be our answer. And you can simplify that to 1/2. That'd be good as well. Either one of these. So with that, let's go ahead and move on to part B of the classwork.